Okay, so what is our next question? Our next question is, how long does it take the ball to reach a height of 80 feet? Okay, so let's just say at this location and at this location, it's a height, it is a height of 80 feet. Okay, so I take, so let's assume that at these two locations, it is a height of 80 feet. Once again, I'm going to write the equation. So I had erased my equation and let me bring it back. It's h of t is equal to negative g t squared plus v naught t plus h naught. Okay, so we have our equation. Now we're going to go ahead and plug in what we had. In this case, since we are asking how long does it take for the ball to reach a height of 80 feet, I'm going to plug in 80 for h of t. And then we're going to solve for t. Okay, so if I have 80, I'm going to put in 80 is equal to negative 16t squared plus 64t plus 48, okay? So now I'm just going to solve for t. My first initial reaction is to make the number that's attached to the highest degree a positive number. And in order to do that, I'm going to need to bring everything over to the other side. Okay, so if I just swap and I take this equation, bring it over to the other side and take the 80 and bring it over to the right side, then I can rewrite this equation as follows. Okay, so can I do that? Yes, I just brought the 80 to the other side and I brought all of the numbers on this side, on the right side over to the left side, which means that the signs will have to change, right? Okay, so now I'm going to do another step. I'm going to take the 80 and just bring it back over so that I can get my equation in standard form. So if I take the 80 and bring it over, then we're going to subtract. Okay, so then we're going to have negative 48 plus an 80. Well, what is negative 48 plus 80? So if I come out to the side and subtract 80 minus 48, 32. Okay, so negative 48 plus an 80 is a positive 32. So now we have 16t squared minus 64t plus 32 is equal to 0. By the way, this is equal to 0. Now we have an equation in standard form where we can use the quadratic formula. But before I do that, I might make my life just a little bit easier and cause this leading term to just have a coefficient of 1. And in order to do that, I need to divide through by a 16. Okay, so I'm going to just divide everything by 16. Okay, and now we're left with 16. And now we're left with t squared minus 4 plus 2 is equal to 0, right? Because 64 divided by 16 is 4, and 32 divided by 16 is 2. So now we have a very nice equation, right? We have an equation in the form of ax squared t is equal to 0, where a is equal to 1, b is equal to, by the way, this is a t attached to that 4, right? Our b is equal to a -4, and our c is equal to 2. So we have a beautiful equation here, and we can use the quadratic formula. The quadratic formula is x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So yes, we can use the quadratic formula to solve for t. So I'm just going to sort of clean up the board a little bit so we can have some room to finish working our problem. So I just rewrote where we left off here. So we have t squared minus 4t plus 2 is equal to 0, and we are going to solve for t. So we're going to use this formula, and where you see the x, we'll just use a t. So t is equal to -b, which is 4, -4, so it's going to be a -4, plus or minus the square root of a -4 squared minus 4 times 1 times 2 all over 2, right? Because we're just plugging in using the quadratic formula. If you need to sort of revisit how to solve for quadratic equations, you can look at a previous video of mine. Okay, so I'm just going to sort of clean it up, and so now we have t is equal to a +4 plus or minus the square root of 16 minus an 8 all over 2, which means that we have t is equal to 4 plus or minus the square root of 8 all over 2. Now 8 can be simplified a little further, so if I take the square root of 8 can be simplified. So if I take 8 and I use a little factor tree, it can factor into 2 and 4. 2 can be factored further into 2 and 2. We have a perfect square here, and we have what's left is a 2. So we take the perfect square and we pull it out, and we leave what is left under the radical. So now we have t is equal to 4 plus or minus 2 root 2 all over 2. And now we want to simplify this some more, okay? So let me, we need some more room on the board. Okay, so I'm going to bring this problem over here a little bit. Okay, so we can break this up because we have the same denominator. So we have t is equal to 4 plus 2 root 2 all over 2. And we also have t is equal to 4 minus 2 root 2 all over 2. Because we have plus or minus, so we're splitting the plus and the minus up. Now we can split the numerator up a little bit. So now we have t is equal to 4 over 2 plus 2 root 2 all over 2. And we also have t is equal to 4 over 2 minus 2 root 2 all over 2. And now I can go ahead and simplify it just a little bit. 4 divided by 2 is 2, so we have t is equal to 2 plus, and then the 2's cancel here, so we can say t plus root 2. Okay, and so we also have t is equal to 2 minus root 2. Okay, so when the ball reaches a height of 80 feet, it happens at time equals 2 minus root 2 and 2 plus root 2. And that makes sense because you have two locations here on the graph where it reaches a height of 80 feet. So if I throw the ball, it has to cross 80 feet before it reaches its maximum step height, and it has to cross 80 feet after it reaches its maximum height. So it reaches at t equals 2 minus root 2 here. So here t is equal to 2 minus root 2. And at this location is t is equal to 2 plus root 2. Okay, and that makes sense because in the previous problem it said that it reached its maximum height at 2 seconds. Okay, so that is how you solve that. Okay, so what is our next question? So our question is, how long does it take for the ball to hit the ground? Okay, well, how tall is the ground? The ground is 0 feet, which I have indicated here. So we are still going to use our equation of an object's height at time t. So I'm going to write out the equation, and it's going to be h of t is equal to negative g t squared plus v naught t plus h naught, okay? Okay, so in this time, instead of, in our previous problem, we asked how long does it take for the ball to reach a height of 80 feet. This time we're asking how long does it take for the ball to hit the ground. Well, the ground is 0, so we're basically asking how long does it take for the ball to reach a height of 0 feet. So we're going to replace h of t with 0. So we have 0 is equal to negative 16 t squared plus v naught, which is 64 t, plus h naught, which is 48. So basically, we have something in the form ax squared plus bx plus c is equal to 0, right? So I want to make my life easier and bring everything on the right side of the equation to the left. Why? Because I want my leading coefficient to be a positive number. So if I just bring everything over to the other side, we have 16t squared minus 64t minus 48 is equal to 0. So when we bring everything over to the other side, the signs change. So now we're getting closer to what we want, but before I tried to solve for t, I want to try to make my life just a tad more easier. So I want to make the leading term to become just a 1. So in order to do that, I need to divide everything through by 16. And once I do that, our leading term can be a 1. So now we have t squared minus, well, 64 divided by 16 is 4. So now we have a 4t minus, and 48 divided by 16 is a 3. Okay, so now we have this situation. So now right away we see it's of the form ax squared plus bx plus c is equal to 0, right? And in our case, our a is equal to 1, our b is equal to -4, and our c is equal to -3. We can use the quadratic formula. The quadratic formula is x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a, right? Okay, so we can use this form for our problem. So in our problem, it's going to be t is equal to negative of a -4 plus or minus the square root of -4 squared minus 4 times 1 times -3 all over 2 times 1, okay? So now I just need to sort of clean it up a little bit. So we have t is equal to 4 plus or minus the square root of 16 plus 12 all over 2. And I'm just going to sort of erase this side so we can have a little space to finish, to continue our work. Okay, so I'm going to bring it on over here. Okay, so now I'm just going to sort of clean it up just a little bit more. So now we have t is equal to 4 plus or minus the square root of 28 all over 2, right? Okay, So now I'm going to try to simplify the square root. Well, if I try to simplify the square root, I'm just going to pull out the 28, factor it a little bit. 28 factors into 2 and 14. 14 factors into 2 and 7. We have a perfect square here, and 7 is what we are left with. So now I can rewrite the square root as 2 root 7. Okay, so now we have t is equal to 4 plus 2 root 7 all over 2, and we also have t is equal to 4 minus 2 root 7 all over 2. Okay, can we simplify this just a little bit more? Sure we can. Why? Because 2 can go into 4, and 2 can also go into 2. Therefore, we can just sort of simplify it just a little bit more. So we're just going to sort of break up the fraction just a little bit more. So I'm just going to focus on this one for now. So I'm going to say t is equal to 4 over 2 plus 2 root 7 all over 2. And right away, 2 goes into 4 2 times. So now we have t is equal to 2 plus root 7. Why? Because the 2's over here cancel. So that is one answer. And if I come over here, I can do the same thing. So t is equal to 4 over 2 minus 2 root 7 all over 2. And also t is equal to 2 minus root 7. Now, we are not going to count this answer. Why? Because it is a negative number. And we don't include negative time in our problem. So, and the way you can verify that this is in fact a negative number, you can just look at your root 7 and see if it's greater than or less than a 2. Because anytime you take a positive number and subtract it from a number that's bigger, then you're going to get a negative number. But how would you be able to tell right away that this is a negative number? Well, you can think of you can take the 7, the root 7, think of the perfect square that is bigger than the 7. Well, the perfect square that is bigger than the 7 is a root 9. And the perfect square that is smaller than the root 7 is a root 4. Okay, so that means that, well, what is the square root of 4? The square root of 4 is 2, okay? So that means we have this situation. So, and what is the square root of 9? 3, okay? So we know that root 7 is greater than 2 and less than 3. Well, since we know that root 7 is greater than 2, then 2 minus root 7 is a negative number. Therefore, we're not going to use that value. 2 plus root 7 is your answer. So the time it takes for the ball to hit the ground is t equals 2 plus root 7. So this happens at t equals 2 plus root 7, okay, seconds. All right. And that is how you solve the equation. Thank you for watching. Have a great day.